Tanya.
I teach CBSE 8 Maths.
I teach CBSE 10th Maths.
Okay, now let's get into the video.
Today we are going to be learning Chapter 13, Surface Areas and Volumes, Exercise 13.2, 7th question. Alright, now let's read the question. A solid consisting of a right circular cone of height 120 cm and radius 60 cm, standing on a hemisphere of radius 60 cm, is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and its height is 180 centimeter. So this is the question. Okay, so there is a solid, so you can say there is a figure or a shape, so which has consisting of a right circular cone. So let us draw a cone. One second guys, so we are supposed to draw the figure right now. Okay, so let us understand the figure. Okay, first we are supposed to draw a cone. Okay, so let us draw a cone. Okay guys, so cone looks something like this, am I right? This is the rough figure, okay? I am not doing the exact one. Okay, so there is a cone. So later on we can mention the height, radius and all. So this cone is standing on a hemisphere. Okay, so this cone, no, it is standing on a hemisphere. So since it is standing on a hemisphere, let us draw a hemisphere. Okay, so this is the hemisphere. So the cone now it's standing upon a hemisphere, right? Okay, so this is the hemisphere. Okay, so till here you understood, right? One second, I'll just little bit. Okay, so now you can see it properly, am I right? So there is a cone and which is standing upon a hemisphere. So later on we can mention the values. Is placed upright in a right circular cylinder. So this word is really important. Placed upright. So what is the meaning of upright? Upright means this entire solid is there. No? This is inside a cylinder. Okay, that is the meaning. Is placed inside. Upright means you can say inside like that. Okay, so when I'll draw now, that time you'll understand. So we are supposed to draw a cylinder. Okay, so let us use scale. It will be much more better. We are supposed to join it, okay. Okay, so this is the figure, okay. Okay, one second, now you can see it, am I right? Okay, so this is the figure, okay. So here this is a cylinder. So in this cylinder, no, the cylinder is filled with water. So let us show that it is filled with water. Okay, since we have figure right over here, no, let us put the water, I mean let us mark it in the rest of the sides. Okay, so this entire cylinder, it is filled with water. Okay, so now this is the rough figure. So I am gonna draw a clear figure. Okay, so this is just a understanding. Okay guys, so now here you can see, now let us mark the values. Okay, okay, so now let us mark the values for cone. Okay, so circular cone, the height is 120 centimeter, radius is 60 centimeter. So where is the height? Yeah, so height is right over here. So the height of the cone is 120 centimeter, right? Yeah, so let us write 120 centimeter and the radius is 60 centimeter, right? Yeah, 60 centimeter. I'll write it here, okay. So radius is 60 centimeter. Okay, and then what about hemisphere? So for hemisphere, radius is 60 centimeter. Yeah, that's all. That is the okay. So for hemisphere also the radius. So here you can see the cone. Cone is standing upon a hemisphere, right? So here the radius for both the figures, no, it is 60 centimeter. Okay, all right. So now let us look at cylinder. a cylinder full of water such that it touches the, okay, and then if the radius of the cylinder is 60 centimeter and its height is 180 centimeter. So here the radius of the cylinder is same, 60 centimeter only, okay. So we can think here it is radius here, so here the radius 60 centimeter, okay, and the height of the cylinder, it is 180 centimeter, okay, 180 centimeter, okay. This is the height of the cylinder, okay. This is the height of the cone, that's why I just put it inside the cone, okay. So for this complete solid figure, no, the radius is 60 centimeter, okay. For cone, hemisphere, cylinder, for everything the radius is 60 centimeter, okay. So what are we supposed to find? We are supposed to find the volume of water left in the cylinder, okay. So since you guys know, this cylinder is kind of like a container, okay. So this container is filled with water, okay, but a thing, so you can just think this shape is, you know, so it is somewhat like this shape, right, okay. This is a I mean not just so here we have a cone and here we have hemisphere, so something like in this shape, no, it is kept inside this container, okay. So do you guys think that this cone and hemisphere is filled with water? No guys, it is just a thing, okay. So it is just something, it is made up of cone and hemisphere, okay. So it doesn't have a water inside it, only the cylinder, no, inside the cylinder there is water. So you can see the gaps, right, only the water is filled only in these gaps, okay. It is not filled inside the hemisphere as well as the cone, okay. Why? Because the hemisphere and cone, it is like this, okay. So it is completely closed, that's why we can't just fill the hemisphere and cone with water, okay. So since we know, we are supposed to find how much water is left in this cylinder. So if I draw the cylinder separately without drawing the cone and hemisphere, so now so now if we just take this out, so if I just take this cone and hemisphere out, then I'll get to know, right, how much water is there inside the cylinder, am I right? How so we are supposed to take these figures, these two figures out. I just told we are supposed to take these figures out. So out means if we remove, so if whenever we are supposed to remove or take it out, whenever we use these words, no, we are supposed to subtract it, am I right? So what we are supposed to do is volume of cylinder minus volume of cone and hemisphere. Okay guys, why am I doing it like that? Why? Because we want how much water is left in the cylinder, okay. To find that, we are supposed to remove these two figures, am I right? We are supposed to remove it like this. So we are just because we want to remove it, we are supposed to subtract it, okay. Then only we will be able to find how much water is there. If we don't just remove it, it is hard, right? Here we have some water, here it is completely it is hard. That's why we are supposed to remove the complete figure, this figure, that is cone and hemisphere. Why? Because these are the two figures which is distracting us, just because we are not able to find the water. So if we just take off this figure, two figures, and then we'll get to know what is how much water is there in the cylinder. So that's why I'm going to be using volume of cylinder minus volume of cone and hemisphere, okay. Okay, so now let us write that. So since the case now we are supposed to find volume of water left in the cylinder. Okay, let's write that. Okay guys, so let's write volume of water left in the cylinder. Okay, so how to find the water left in the cylinder? I just told you guys that I am going to be writing volume of cylinder. First let us write that. So volume of cylinder, and then I am going to subtract it, right? Subtract minus volume of solid. So what is the solid according to the question? So the solid is, one second. So here you can see. So in this, which one, according to the question, they mentioned the cone and hemisphere is solid, right? That's why I mentioned it. Okay, so we are supposed to write cone plus hemis. I'm just writing short form. Okay, so cone plus hemisphere. Okay, why? Because volume of solid, we are supposed to subtract it, right? So in that solid, no, we have cone as well as hemisphere. That is what we are supposed to remove, right? We are supposed to remove cone and hemisphere, and since they are attached, no, that's why I just wrote it like that. Okay, so now we can apply the formula. So what is the volume of cylinder? So the volume of cylinder is pi r square h. So one more thing I would like to say is, so since we have two height here, so here we have height for cone and as well as we have height for cylinder, right? It is a little bit hard to differentiate. Okay, so I am going to take capital H for cylinder. Okay, I am going to take capital H for cylinder, that is 180 centimeter, and small h, that is for cone 120 centimeter. Okay, I am just differentiating them. Okay, so I took height of the cylinder is 180 centimeter, so I just represented it with capital H, and for cone I represented with small h. Okay, so let us write. So volume of cylinder is pi r square. So here h is capital. Okay, I just took it as capital, and then minus so volume of solid, so that is cone plus hemisphere. So what is the volume of cone? So let us write it in bracket, it will be much more better. Okay, so what is the volume of cone? So the volume of cone is 1 by 3 pi r square. So for cone I took the h as small h, so small h plus, and what is the volume of hemisphere? So the volume of hemisphere is 2 by 3 pi r cube. Okay, so we are supposed to solve this. Okay, let us solve it. So now what we can do? Okay, so now we can take them as common. Okay, so how to take it as common? It is easy, guys, believe me. So how means, so I am going to take common for the three values. So here pi r square capital H, and then minus okay, bracket. So just because for good understanding only I just put bracket. Okay, and then 1 by 3 pi r square small h plus 2 by 3 pi r cube. So we are supposed to compare 3. In these three formulas, no, which one is common, we are supposed to write it. Okay, so here I have pi, here also I have pi, here also I have pi. Can I write pi as common? Of course I can write pi as common, and then here I have r square, and then here in this question I told you guys, for the complete figure the radius is 60 centimeter in case of cone, hemisphere and cylinder. Okay, so here also we have r square, and here we have r cube. In this r cube, no, let us take r square as common. Okay, so let us take r square as common. So here we have capital H, we can't just take anything as common. Why? Because we are supposed to compare these three things, am I right? So that's all, I guess. Yeah, now we can actually write it in bracket. So we can write H, capital H as it is, and then minus, and then what about here? Here we just took these two as common, and then we can put bracket. So 1 by 3 into h, 1 by 3 into small h, and then plus as it is, and here we have 2 by 3, and then I took pi as common, r square as common, and one radius remaining, right? So let us write that, and then close the bracket. Okay, alright guys, so now we can substitute the values. So for now no need to substitute pi value, later on we can do it. So we can substitute rest of the values. So what is radius? So radius is 60 centimeter. So here we have square, so let us write 60 square. Okay, and then bracket, and then capital H is the height of the cylinder, that is 180, and then minus, and then here 1 into h is h, of course you guys know it will come, 1 into h is h, right? Once again, then it will be h by 3. So what is the height? So the height of the cone is 120, right? So let us write that. So in bracket 120 by 3. Okay, Alright, so I just did directly, okay, so don't get confused. And then plus as it is, and then 2 by 3 into radius is 60, close the bracket. So we are supposed to cancel it, so be careful here. So guys, you are supposed to be careful in this part, okay? Why? Because you guys might commit a lot of mistake in this part while cancelling. So now we didn't substitute pi value, right? So before substituting the pi value, we can actually cancel a few values here, right? So let us do that, okay? So we can cancel 3 and 120 in third table. So 1 3 is 3, and then 4 3s are 12 and 0 as it is. Here we can cancel this 3, 1 3 is 3, 3 2s are 6, 0. Okay, that's all I guess. Yeah, of course. So now we have 180 minus, okay, 180 minus, and then we have 40 plus 20, right? I guess, yeah, 40 plus 20. Now guys, here we have 40 plus 2 into 20. Okay guys, so now we can substitute the pi value and then we can solve it, okay? So here we have 40 plus 2 into 20. So 2 into 20 is 40, okay? So now let us substitute the pi value at first. Okay, so now the pi value is 3.14, am I right? Okay, and then we have 60 square. So 60 square means 60 into 60. And then we have bracket, and then we have 180. So I just told you guys, and then we have minus, okay, 1 second, and then bracket we have 40, and then here I told you guys that 2 into 20 is 40, right? So here plus 40. So let us add plus 40 and close the bracket, okay? Alright guys, so now we can take off this point. So when we just take off the point, it becomes 100, okay? So now what we can do, now we can write them as it is, 314 by 100 into 60 into 60, and then big bracket, and then 180 minus, so 40 plus 40 is 80. So let us write 80 and then close the bracket. Okay, so here since you guys know we have 100, here we have 60 into 60. We can cancel the zeros, right? So let us cancel the zeros. Okay, so when we just cancel them, we have 314 into 6 into 6 is 36. Okay, and then 180 minus 80 is 100. So since it is in bracket, so let us write into 100. Okay guys, so when we just solve them, so when I just multiply these values, I get a number, that is this number. Okay, so centimeter cube. Okay guys, so why did I write centimeter cube? So why? Because we found the volume, right? So volume in centimeter cube. Okay, so you can just leave the answer right over here. Otherwise, if you want to convert to meter, so what you can do is you are supposed to divide it with 100. Okay, so with how many hundreds we are supposed to divide? So we are supposed to divide it with 300. Okay, why am I dividing it like this? Why? Because if you want to convert to meter, not just a meter, meter cube. Okay, so remember guys, so whenever you want to convert centimeter cube to meter cube, no, you are supposed to divide it with 300. Okay, so if you have centimeter square and if you want to convert to meter square, then 200 is enough. Okay, so since we have centimeter cube, we are supposed to convert it to meter cube. We are supposed to divide it with 300. Okay, so when we just divide it with 300s, we get 1.13 meter cube. Okay, so you can write the answer, you can write this as answer, otherwise you can just write this as answer. Okay, I mean you can just leave the answer till here, otherwise if you want to convert it means you can just do it. Okay, I just thought you guys, you should know. Okay, in some cases and all, know, we might apply this. Okay, so so if you want to write this as an answer, you can write it. If you want to convert means you can just do this. Okay, so this is our final answer.
Thank you guys for watching this video. Please like this video, share it to your friends and subscribe to our YouTube channel. If you have any doubt, comment me in the comment section. Catch you in the next video. Bye.